exponents. So exponents basically means how can we simplify some equations or expressions that have exponents. Now there's a few rules that we should know. For example, if I have x to the n raised to the m, that's equal to x to the n times m. That's a very important rule to remember. And another one very similar to that, but kind of opposite, is x to the n times x to the m. That's equal to x to the n plus m. So I remember this as if you have something to a power to another power, you multiply them. And if you have the two bases to different powers, you add the powers. These are two of the most important rules, and I'm going to add in a third, that if you have a negative power, it just means 1 over that x to the power. Now, there are other rules of exponents, but I am just covering the things that I think you really need to know before you take calculus. And I'd say these are the most important exponent rules. So let's go ahead and do an example of this. Here we have 2 cubed, and that's going to be squared. Now, I want to point out before we start, this is something that I was actually in calculus when I personally realized the error of my ways. This is not the same as 2 to the 3 squared. These are two completely different things. So be careful about that. These are not the same because this one is 2 to the 9th. And this one, as we'll talk about now, this is 2 to the 3 to the 2. Well, that's something to a power to another power. You multiply the powers, you get 2 to the 6th. So that is very different. These are not the same thing. Be very, very careful about that. I nearly failed my calculus class because of that. So let's go on to the next example. So this one is very, very similar to the last one, but I feel it's fairly quick and important. So we're going to have 2 to the power raised to another power. So we multiply the powers, and we get 2 to the 12th. All right, one more. So here we have x cubed y to the negative 1 over x to the negative 3. And let's just simplify this down. Let's drop all the negative powers and only write each variable once. So we have a choice in how we go about all of these problems. So one thing you might try and do is just write it without any negative powers first, because negative powers, if you ask me, are confusing. Now this rule right here directly says that if you have a negative power, it's the same as just dividing by it. But I'm going to take that a step further and say that this rule means that you can take a negative power and switch it freely between numerator and denominator if it's a negative power. So really this y, I think of it as actually this y is in the denominator. Likewise, this x is actually in the numerator. So we have this x cubed that didn't get changed. And I'm going to take this x cubed here and move it to the numerator. Just change the sign. If you move it between numerator and denominator, you just change the sign. And then the y gets moved as well, so that one becomes just y to the first power is where that one went. So a negative power just means change where it's at. If it was in the numerator, put it in the denominator. If it was in the denominator, put it in the numerator. So now this y is as simplified as it's going to get. I'm not going to touch that. But we can simplify the x cubes. We have x cubed times x cubed. That's going to be this rule here. We have x to a power times x to another power. We're going to add the powers. So that's going to be x to the 3 plus 3 is 6 over y. So that's x to the 6th over y is our answer. That's as simplified as we can get. All right, let's look at another one. Here we have x cubed y over z to the negative 2, and it's all raised to the negative 1, and that's multiplied by z to the 4th. So again, let's try and eliminate the negative powers first. Before we really get started, let's just get rid of all the negative powers. So let's start off with this z to the negative 2. As we talked about before, we can just move that to the top. So that becomes x cubed y and z squared. We just drop the negative. But that is raised to the negative 1 power. The whole thing is raised to the negative power. And we're multiplying by z to the 4th. So that basically means that this thing right here is all in the denominator. So I'm going to change this to 1 over x cubed y z squared. And that's going to take this negative power, and that goes away now. And then we multiply by z to the 4th. Now I have purposefully written this in a nasty way Because what do you do with this z to the fourth? I didn't write it as a fraction. So there is an understood over 1 here. And if you want to think of it that way, that's great. You can do that. But what I like to do is I just like to think of everything as, is it in the numerator or is it in the denominator? Well, the z to the fourth, there's no division, so it's in the numerator. So this is z to the fourth divided by x cubed y z squared. It's the same thing. And then finally, well, I didn't write out the exact rule. There's another rule that I didn't actually write here, and that's that if you have x to the n divided by x to the m, that's equal to x to the n minus m. Now, why didn't I write that? It's because you don't actually need it, and I don't like memorizing extra rules. So while this is true, and a lot of textbooks would show you that and say that's what you need to memorize, I don't like it. Instead, I'm going to put these in the same place. So I'm going to say this is z to the fourth times z to the negative 2. I know we're kind of going backwards, kind of getting rid of putting our negative power in, but now we can directly use this rule so that we don't have to memorize this last one. And it basically says that if you divide, instead of adding, you subtract. So if you want to just remember, if you just remember that division gives you subtraction, however you want to do that. But in any case, we say 4 minus 2, so 4 plus negative 2 is 2. So we have z squared over x cubed y. So that's how I would simplify this thing. That's quite a bit simpler than what we started with. I do have one more example, so let's do that. So now it's getting a little more complicated. We have z to the negative 1 x to the fourth over x cubed x to the negative 2. And that's going to be divided by x cubed z to the negative 2 over x. Whew. All right, so earlier I said let's start by eliminating the negative powers. And if you want to do that, go ahead. But one of the things I love about math is there's so many different ways. Pick and choose. I'm probably not going to do this problem the same way twice. So what I'm going to do, I'm actually going to just ignore these negative powers and say, I don't care. Instead, let's simplify a little bit. So this x cubed times x to the negative 2, that's just x. And when I do this x to the fourth divided by x, remember we're going to subtract those powers. So we get power of 1, so 4 minus 1 is 3. So this first fraction is just z to the negative 1 times 3. Oops, why did I say 3? Nope, it's x to the third. Now I'm going to divide. This is just a real quick reminder, hopefully you remember, but when you divide a fraction, that just means flip it and multiply. So I'm going to multiply by flipping it. So x over x cubed z to the negative 2. Now I could have probably simplified this before I did it, but oh well, I didn't do that, doesn't matter. So this becomes an x squared in the bottom. Notice that you subtract the powers and whichever one's bigger is the one that wins. So the x cubed is bigger than the x, so we're going to keep that x squared in the denominator. So again, I'm going to think of this, we could think of it as, hey, this is over 1 and multiply across. But instead, I like to just think of what's in the numerator. We have a z to the negative 1, which, yes, technically, we could get rid of the negative power, move it to the denominator, but I'm not doing that right now. X cubed, and then we have this other x from the other fraction in the numerator as well. Oh, sorry, I apologize. I forgot, that went away. We don't have that x anymore, right? So that's all that's in the numerator. And then we have this x squared from the second fraction, x squared. And then we also have that z to the negative 2. So let's go ahead and simplify this further. So I'm going to move this z to the negative 2 to the top and become z squared. Times the z to the negative 1, well, that's just simply z. So that x squared is kind of in my way, but let's just call that z. And then for the x's, we have x cubed, and we'll subtract the 2, so x to the 3 minus 2 is just x to the 1. So this is just xz. That's all we have left. So I would say that's everything you need to know for calculus for your exponents.